Hello everyone, this is Unit 6, Lesson 4, Multiplication with Exponents. The iXL code associated with this lesson is on the screen. Let's go ahead and get started. For this lesson, you will need paper and a writing utensil. I will be giving you practice problems for you to work on to prove to yourself that you understand what you are doing. Calculators for this lesson are optional. However, I would encourage you not to use a calculator and push yourself to do some of that basic addition by hand. It's good practice and it just makes sure that you really understand what you are doing. As you can see here in red, this is a very important lesson. This lesson is going to serve as the foundation for what we're going to be talking about in the next few lessons. Again, I just need to make sure that you understand the thinking process. So please do your best to pay attention. If you have questions about this lesson, please let me know. Reach out to me either on Remind or on Zoom. And with that, let's go ahead and get started. Here is an overview of what we're going to be talking about in this lesson. Parts 1 and 2 are going to focus on basics. We're going to just establish a foundation, making sure that we understand the basics of what we are learning. And then in part 3, we're going to bring in something called the commutative property of multiplication and see how it relates to the things that we're going to be learning. All the problems that we're going to be working on in this lesson are going to ask us to simplify. In this case, we are being asked to express our answer using only positive exponents. If you remember from the other lessons, we were working with bases that had some sort of number as the base. But in the examples that we're going to work on today, our bases are going to be variables, not numbers. This means that our answers are not going to be just a single number. Instead, it's going to be an answer that has a variable as the base instead of a number. To simplify this, we first need to start by thinking about what this is saying. What does this mean? Let's start off with this c to the power of 3. We know that the exponent is telling us that our base, c, is being multiplied by itself 3 times. We're going to bring down the multiplication from the center, and then same thing with c to the power 4. That just means c times c times c times c. What we just did has a name. In math, we call this expanding. When you expand something, if you think about the word, expanding means to like pull out, to like stretch, or to make longer. And that's exactly what we just did to this problem. And now that we expanded, we could do the next part, which is to simplify. To simplify, we're just going to ask ourselves, what does this whole thing mean? In this case, we just see c and we just see multiplication. This is just repeated multiplication. That's why we use exponents. Whenever we have a base, in this case c, that is being multiplied by itself multiple times, we just write down the base, c, and then count how many times it was being multiplied by itself, or just how many c's do we see. We have 3 at the beginning, 4 at the end, so that is to the power of 7. This is the same thing as saying c to the power of 7, and that is our answer. We are doing the same thing for this example. We're going to start off by doing step 1, which is going to be to expand, and then after we expand, we are going to simplify it. We're going to make it smaller. So expand. We're going to take x to the power of 3 and write it out as x times x times x, times same thing with x to the power of 2, which is just x times x, times, and then the same thing for x to the power of 4, which is just x times x times x times x. Next, we're just going to ask ourselves, how can we rewrite this whole thing with an exponent instead of writing this thing multiple times, writing it out multiple times? Here our base is x, so we're going to write down x, and then it's being multiplied by itself. Well, 3 at the beginning, 2, and then 4. Well, that is just 9. So x to the power of 9. Let's see if you understand this idea of expanding and simplifying. Here are 3 problems. You have 1 minute. Give it a shot. If you need more time, go ahead and stop the video and then press play when you are ready. Your time starts now. That was 1 minute. Let's see how you did. Step number 1, let's go ahead and expand y to the power 2 and y to the power of 7. Y to the power of 2 is just y times y to the power of 7 is y times y times y times y times y times y times y. Next, let's just count how many times y is being multiplied by itself. Y is being multiplied by itself a total of 9 times right here. 2 and then 7, a total of 9 times. For the second example, we have d times d to the power 4 times d to the power of 2. The first d, it doesn't have an exponent, so I'm just going to go ahead and bring it down. We're going to multiply that with d to the power of 4. That's just d times d times d times d. And then the last one is d to the power of 2. So we have d times d. In total, d is being multiplied by itself, 1 at the beginning, 4 in the middle, and then 2 at the end for a total of 7. That means that our original problem is the same thing as saying d to the power of 7. Same thing in the previous problem. Y to the power of 2 times y to the power of 7 is the same thing as saying y to the power of 9. For this last one, I'm going to go ahead and give you the answer first. This is x to the power of 25. By now, you've probably recognized that there's a pattern and there's actually an easier way to do this than having to expand every single time. And that's exactly what we're going to talk about. Because for this example, x to the power of 5 and x to the power of 20, it's going to take too long to write that over and over and over and over again. It's not necessary. So let's go ahead and talk about a faster way, an easier way to do these type of problems. Let's try these problems one more time. But this time, instead of doing expansion, instead of rewriting it over and over on our paper or on my screen, we're going to do that step in our head. For number 1, we have y to the power of 2 times y to the power of 7. Because both of these have a base of y, that means that our answer is also going to have a base of y. Remember, this is just repeated multiplication. We have the same variable being multiplied by itself over and over. We know that we're going to have 2 at the beginning, 7 at the end. We could actually just add 2 and 7. That's going to give us our final answer. So this is y to the power of 9. We're going to do the same thing for x to the power of 5 times x to the power of 20. So here we have x as our base. Again, they have the same base. That's why this works. We have 5 from the first one, and let's add 20 from the second one. That's going to give us a total of x to the power of 25. Just to be clear, the long way still works. We could write x times x times x 5 times and then again 20 times, but that's not necessary because we know that an exponent tells us exactly what that would have said. It's telling us that x is being multiplied by itself a total of 25 times. We just don't need to write it down. This is just easier. This idea that whenever you have the same bases and you just add the exponents, that is a very huge idea in this unit. It's called the product of powers. The shorter way of finding your answer is by taking your base and then just adding your exponents. The same thing that we just did. This is so important. That is why the text is in gold. I am giving you gold. It is that important. And to be clear, this only works because we're trying to skip the expansion step. Expanding always works. We just don't want to have to deal with that. It's way too much. Let's see if this made sense to you. You have 3 problems, 30 seconds. Go ahead and get started. If you need more time, press pause. Press play when you are ready to start. 30 seconds starts now. First problem, r to the power of 4 times r to the power of 22 times r to the power of 12. They all have the same base, so I know that my answer is going to have an r. I have 4 from the first one, plus 22 from the middle one, and then 12 from the last one. My answer should be r to the power of 38. This little one is a little different. The g doesn't have an exponent, but like we talked about in a previous lesson, it actually does have an exponent. It's invisible. It's an invisible 1. So here we're going to do the same thing. This is g because both of our bases are g in this problem. And then we're going to take 1 from the first one plus 99 from the second one. Our answer here is g to the power of 100. We haven't done an example where our exponent is 0, but the same thinking applies. Our base is b. We have 2 as our exponent for the first one, plus 0 as the exponent for the second one, which means that our final answer here is b to the power of 2. Everything that we just did was the basics, the foundation for what we're about to talk about. This next part is the part that really matters. We're going to talk about what happens when we don't have the same base. What if we have different bases? These are the two examples that we're going to start off with. They look very similar with one major difference. The first example has x's as the base, and the second example has an x and a y as the base. If you would like, give this a shot on your own, pause the video right now, see what you get as your answer, and then continue. I'll give you 5 seconds to decide if you want to do that. I believe that was 5 seconds. Let's go ahead and get started right here. To make sure that we understand what the difference is, we are going to expand, just like we did at the beginning of this video. Here we have x to the power of 2, and we don't have a symbol here. But whenever we have two variables next to each other, this automatically means multiplication. So it's the same thing as before. Nothing has changed. X to the power 2 means x times x to the power 3, which is x times x times x. And on the other side, we have x to the power 2, which is x times y to the power of 3, which is y times y times y. Let me fix that y real quick. I hope that's better. So now that we expanded, let's go ahead and simplify. Back to the first example. X times x times x times x times x. No one has time for that. This is the same thing as saying x to the power of 5. That's so much easier. X is being multiplied by itself 5 times. That's what the exponent means. Second example, here is the wrong answer. This is not correct. Our answer here is not xy to the power of 5. That is not what this says. So if that's what you wrote as your answer, please pay attention. Let's look back at number 1 again. The only reason x to the power of 5 is correct is because x to the power of 5 is x times x times x times x times x, which is the same thing that we had before. The big multiplication symbol doesn't make a difference. X to the power of 5 is x being multiplied by itself 5 times. I know I've said it many times, it's that important. But over here, we have two different variables. The same technique that worked before is not going to work here. X times x is just x to the power of 2 times y times y times y is y to the power of 3. They're different variables. That's the most that I can simplify them, which means that I didn't change this. This was already simplified. These two are the same. All right, everyone. This is what we came for. These are the type of problems that truly matter. Everything else was just an introduction. This is what is important. In the last problem, we talked about the difference between having the same base and having different bases. But in this problem, if you notice, we have both. We have x's as our base, so they're the same, but we also have different bases like y's and also z's. And even though there's no symbols between the variables, like we talked about before, all of this is being multiplied. And that's a very important piece because of something called the commutative property. There's actually two different types of commutative property. There's one for addition and one for multiplication, but they say the same thing. The commutative property says that A times B is equal to B times A. This means that the order in which you multiply two numbers doesn't change the answer. Your answer is still the same thing. The order doesn't matter. And because of that reason, in our problem, the same thing applies. It doesn't matter which way you multiply all this, you should still get the same answer, which means that we're going to reorganize the variables in a way that's a little easier for us to understand. So first I'm going to start by moving my x's together. I have x to the power of 4 times x to the power of 2. I'm going to do the same thing for my y's. So all this is being multiplied times y to the power of 2 times y to the power of 5. And last but not least, we have z. So times z to the power of 3 times z to the power of 4. And now that everything's organized, it's similar to the previous problems that we did. Let's focus on the x's. X to the power of 4 times x to the power of 2 is the same thing as saying x to the power of 4 plus 2. That's going to be multiplied by y to the power of 2 plus 5. And that is going to be multiplied by z to the power of 3 plus 4. Which brings us to our final answer. We have x to the power of 6 times y to the power of 7 times z to the power of 7. To recap, this first problem right here is the same thing as saying this. X to the power of 6 times y to the power of 7 times z to the power of 7 is the same thing. It's simpler, just like the problem asked. This is your last problem. You have 30 seconds. Let's see if you're able to do this during that time. If you need more time, just press pause and press play when you are ready. 30 seconds starts now. And that's time. If you get this answer correct, that means that you are ready to do your iXL assignment. If you get this answer incorrect, either please go back and review the parts that you might have skipped, or just make sure that you watch the video one more time, or stop by during office hours. That's why we have office hours, for you to ask questions. Let's talk about this problem now. Here we have bases of x, we have bases of y, and we only have one base of z, but that's okay. We could still do the same thing that we did in the previous problem. I'm going to reorganize this by bases just to make sure that it's a little simpler and easier for me to understand. First, we have x to the power of 4 times x. Next, we have y to the power of 0 times y to the power of 5. And last, we have z to the power of 3. Some of you might be asking yourself if the order matters. Could you put z at the beginning, or could you put y at the beginning and x at the end? You can if that's what you want to do. The reason we choose to organize it like this is because it's alphabetical. That's it. Please don't forget that this x here has an invisible 1 as the exponent. So when we simplify x to the power of 4 times x to the power of 1, this is the same thing as saying x to the power of 5. We just add 4 and 1. Then we have y to the power of 5, because 0 plus 5 is 5. And at the end, we just have z to the power of 3. We didn't have to simplify that one, but it's still part of our answer. And that is it. If you got this, then you're ready to move on. If you messed up somewhere, please come talk to me. I am here to help you. Thank you for making it to the end of the video. As you can see, I moved things around. What used to be up there is now over there. Your iXL code for this assignment is HQD. When you get there, you're going to realize that it's pretty easy to get all the way to 90. And because of that, I need you to at least get a 90. If you want to prove to me and if you want to prove to yourself that you really understood what you learned in this lesson, you should be aiming for 100. You can all do it, you just need to try. And that is it. If you have any questions, please message me on Remind or stop by my Zoom office hours. I'll be there to help you out. Take care, everyone. Have a good rest of your day. See you all later. High five.